Hi there everyone! Welcome back to another weekly math video. My name is Christy and I am a math teacher and also a one-on-one math tutor. And I enjoy bringing you these weekly math videos to teach you just a little more about various math topics. And I hope that you're finding my channel helpful. If you haven't subscribed yet, make sure to click that subscribe button. And today we have a very interesting video coming at you, and it is how to calculate the number for phi. And there are different ways you can think about this, but today I'm going to show you my personal favorite way to calculate the number phi, which is also the golden ratio. And my favorite way to show how to find phi is using the Fibonacci sequence, one of the most popular sequences of all time. And the Fibonacci sequence is 1, 1, 2, 3, 5, 8, 13, and so on. And some of you may already know about the Fibonacci sequence, but some of you, it may be the first time you've ever seen it. And the Fibonacci sequence takes on a very interesting form, and it is what's called a recursive sequence because every term of this sequence is defined by the previous terms. And you may recognize that the way you get the next term is it's the sum of the two previous terms. So we can define the Fibonacci sequence recursively as so. To get the nth term of the Fibonacci sequence, it is the two previous terms added up. So the n-1th term plus the n-2nd term, I guess is how I would say that. So the number phi is defined by this. If I go out as far as we possibly can in the Fibonacci sequence, as far as we can, which means out to infinity. And if we go all the way out to infinity, which is kind of thinking about a limit, the limit as n, the nth term, goes all the way out to infinity. If I take the ratio of a number in the Fibonacci sequence and divide it by the number that came prior to it, this will be the number phi. And today in this video, we are going to calculate what the actual number is. And like I said, this also happens to be the golden ratio. And I hope you find this helpful. I love when people write comments. So if you are so inclined to write a comment, it helps people find this video just like you. So let's go ahead and calculate what is phi. So the first thing I'm going to do is I'm going to rewrite the numerator using this recursive formula that I defined over here on the right. So the numerator becomes f of n minus 1 plus f of n minus 2, and then all over that denominator of f of n minus 1. From here, I'm going to do a little bit of algebra. I'm going to divide each of those terms over the common denominator. So I would get f of n minus 1 over f of n minus 1 plus f of n minus 2 over f of n minus 1. Now we're going to do some simplifying of phi. We would have the limit as n approaches infinity of 1 plus the limit as n approaches infinity of f of n minus 2 over f of n minus 1. And I'm running out of room, so I'm just going to come up here. So the limit as n approaches infinity of 1, well, that's just 1. Plus, now if we look at this one, the limit as n approaches infinity of f of n minus 2 over f of n minus 1. That would be the ratio of a term divided by the term that comes after it. Well, if we look up here at how phi is defined as the limit as n approaches infinity of a term divided by its previous term. So what we have in that second part is we really have the reciprocal of phi. And so now we have the equation phi equals 1 plus 1 over phi. To solve this algebraically, I'm now going to multiply both sides by phi. That'll allow this phi to cancel out from the denominator. And I have phi squared equals phi plus 1. Now I'm going to set that equation equal to 0, and I have phi squared minus phi minus 1 equals 0. Here I have a quadratic equation that I'm going to solve using the quadratic formula. So phi equals the opposite of b, positive 1. So a is 1, b is negative 1, and c is negative 1. So into the quadratic formula, phi equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 divided by a. Simplifying this, I would have 1 plus or minus the square root of 1 plus 4 is 5 over 2. And we are just about there. We're just about there to the golden ratio. Because we are finding the ratio of a very, very far term out in the Fibonacci sequence divided by the term prior, we can see that that ratio is going to end up being a positive value. Therefore, I'm only going to take the value of 1 plus root 5 over 2 rather than 1 minus root 5 over 2. And there we have it. Phi, the golden ratio. 1 plus root 5 over 2. All using the Fibonacci sequence and defining it as a recursive sequence. I hope you found this video helpful in determining what is phi and how to calculate it in my personal favorite way. And if you did, make sure to give it a like. Again, comment below, so likes and comments allow people just like you to be able to find this video. And if you haven't subscribed yet, make sure to click that subscribe button so that you're notified of more weekly math videos as they are posted. Have a great day, everyone, and we'll see you in the next video.